everyone, it's Judy Warner. Welcome back to the third installment of this special podcast series created between the Ecosystem Podcast and Keysight Learning. Today, I'm delighted to be joined by Heesoo Lee, who's the high-speed digital lead at Keysight. I'm also joined by his friend and colleague, Ben Dannan, who is a technical fellow and also principal engineer at a Tier 1 defense contractor. We're going to talk about what it takes to successfully navigate the engineering journey from concept all the way to test and measurement. And these two pros are going to give you so much rich information to help you really upskill and have the right stuff to manage today's complex design and development. Make sure you go like and subscribe on Keysight Learning's platform. And also, I'd be privileged to have you over at theecosystem.com. Now let's jump into our conversation with Heesoo Lee and Ben Dannan. Hi, Heesoo. Hi, Ben. Thank you so much for joining me today on the podcast. Glad to have this discussion with you too.
Always a pleasure, Judy.
Well, Ben, I want to jump right in with you, and I want to ask you a bit more. I know you've told me in previous podcasts that, you mostly work on ASICs now, but you think of yourself as a systems engineer. So can you tell our listeners a little bit about the type of systems that you've worked on and sort of what your journey has been and maybe a couple things you've learned along the way?
Sure. Yeah. I mean, I started my career working at a defense contractor with ground combat systems. So anything that moved, that went to the Marine Corps or the Army, I touched it. Integrated LRUs, which are just basically boxes with circuits or circuit boards, and did cable design to full systems. Then from there, went to moving cameras at a security camera company. And then after that, robotics. And now I'm at another defense contractor, and I've launched my own company supporting other clients doing similar systems. And in all of these, the problems are complex in all these systems. And what I find consistently with all of these systems is to be an engineer today is harder than it's ever been. And what that means is that you need to be able not only to design a circuit board or understand that, but be able to measure and understand what you're measuring and being able to model and make those correlations and understand when you have a good model. So you can make a good assessment of a design and sign off to make sure your system's going to work.
So along those lines, what recommendations would you have? Because, your message that is being an engineer is more complex than ever, I've heard resonate across many conversations I've had. So do you have some general recommendations about how to do that successfully, or at least a couple bites from your wisdom and experience?
Sure. Yeah, it's hard really to be a jack of all trades today. I would, when I was in the Air Force, we used to have we had a patch for our class in my flight school, and it was jack of all trades, master of none, right? And so it's not easy as an engineer to say the same. And so to your point, Judy, what I would advocate for is the best engineers I know today are constant learners. With the speed of technology and where things are going, you have to be a constant learner. And so you can do that a couple different ways. You could do that by constantly picking up new books and reading those. I do that as one aspect of what I do. I'm on other committees, so I'm plugged in, and I try to work with great engineers like Heesoo Lee here and many others, so I can stay abreast of what they're doing and what they're seeing from other customers, and so that allows synergy and alignment. And then on top of that, there's always new challenges, things you can talk about. So I would advocate to pick a conference and go to that conference and strive to present or write, because if you are doing that, you're presenting new topics every year. You're doing that, and you're learning and mastering those new topics. DesignCon's one, as you know, the IEEE is another, and Keysight is a big proponent there. And so you're always going to see folks like Heesoo Lee there supporting those sort of aspects.
Speaking of a DesignCon, part of the reason why I wanted to have this conversation with you both is we are all gearing up for that show now. Mm-hmm. And Ben, you and I did a podcast a year ago at DesignCon, and I think I'll link that below, which is actually a good call to engineers of how they can participate in DesignCon. And it's been really fun over the last several years to watch your journey there from, almost sidelines, but you just threw yourself in the middle of that. And now you are doing so many things, and watching your skill grow has been really fun. And as Eric Bogerson often says, and I've heard Tim Wang Lee say, parroting him, is hope cannot be part of the design process, right? Not these days. Things are too smoking fast. Heesoo, what would you say, as sort of a veteran engineer with much engineering depth, are the most important skills and tools that engineers need to use today to sort of upskill and be sort of the Swiss Army knife of engineering talent?
Yeah, that's a great, question. Interesting, I feel that it's a little bit strange to say, because you're talking about the other tools, right, and skill set. But I have to say, engineering curiosity is one of the most important thing from my point of view. Is because tools doesn't start until engineers switch button, right, and construct the schematic, and push the button, go and they run simulations. And also, top of it, when the simulator finish the simulation and get the result for end users, then how are you going to interpret it, right? So this is where engineers' fundamental, understanding on a steps, what they are doing, and also top of it, what if the result is different than what they expected? They must have the engineering curiosity, dive into more detail level to understand what's happening, right? So it's not learning about where is the menu pick, right? It's not something related to what buttons I need to press. It is engineering a fundamentals that drives the quality of the design, and getting all the results right. So from my kind of background or history of my career, I think engineering curiosity is always number one, and the second is always thinking about why, right? Continuous questions on why, that is also very, very important. I learned that by making a lot of mistakes. Top of it, one more thing I like to say is what if questions. You got to ask what if, because although design may look good, but there are areas for the improvement. And you really need to keep thinking about what if, I change this topology, or I change this, circuitry, what happens, right? But these days, it's a lot easier to do that. When I think about, let's say 40 years ago, or 30 years ago, people were sitting at the bench and picking up the, components and try to, replace them, which is very time consuming. But these days, tools are there to help engineers to get the job done better. It's because instead of doing all the work at the, test bench, they can actually do that in the simulation environment. That's where your tool comes in, really helping the engineers a technical or, baseline understanding to make all the, a product what they're designing to the next level. So that's kind of, my story I wanted to share.
So what I hear you saying is it's not, the tools are great, but you also have to have that good engineering intuition and judgment. Do engineers gain that in any way by just getting their hands dirty? I mean, you can't just, you can go, say, to DesignCon and read some books, or you have tools like, is there any other way besides just jumping in and doing it?
Yeah, I think that's an excellent point. Actually, if you see the other kind of papers coming out, you must have a chance to validate it, right? It's not just picking it up by reading it, and you really need to put all the things on a paper or, in the software, try it out and validate. There might be some other better way to go with. One interesting example that was probably happened 20x years ago. My career started with our microwave circuit design engineers, and then I started to work for Hewlett Packard, doing the design with using the EDA. And when I met the one customer, he asked a very interesting question and saying that how good your tool is. From my perspective, I was thinking, wow, this is a difficult question. And anybody can say our tool is good, right? But it's all relevant and probably not hitting the points. And I was thinking, just reflecting myself, and I started to say, tool is always good. However, more important thing to determine the quality of the tool is your engineering knowledge. And I was using the other one example, which is a more of the Smith chart that comes with a complex plane data. So there was the more about data showing a pigtail. And when I ran the other simulation, it came out with that data, very easy, no problem. But the question is, what's the meaning of that pigtail, right? Because, when people are using the any software, it may come with that data. But the interesting thing is, if you don't understand the meaning of the pigtail, you don't have the really good understanding on your circuit, what you are designing. So combining this, tool is going to help to build up their knowledge better or making their design better, without having this, a fundamental knowledge. I think, it's going to be pretty tough. Tool is pretty much similar or same level, but what it makes things different so much is basically an engineering knowledge for those people, have.
Right.
That was, one thing I learned that a pretty interesting way.
Yeah, we had talked about this before, and I really resonated with that moment that you had in your career, because I had a friend who was a really expert at PCB layout, and he did a talk one time at a conference I was hosting, and he was teaching a whole room of engineers. He's like, if you're an expert NASCAR driver, you can handle a Volkswagen or a Ferrari and drive it with skill, right? It's the driver is a key, which is the engineer in this case, right? That there's a variety of tools, and no matter what tool you use, right, it's about being, having that engineering excellent and onboarding, all the knowledge, the intuition, and knowing when you push that button, you get a result. Well, so what? Like, what does it mean? So I think it's really interesting to hear through both of your perspectives as practicing engineers, and sort of how you've learned along your journey. Ben, what in your experience are the best methods or platforms for learning? We talked a little bit about books and DesignCon. But also, I know, because I've sort of watched from afar a bit of your journey, and I'm sure you have much to say about sort of taking ownership of your career, which is something I've encouraged engineers to do, but only as an outsider, right? As an insider, how do you really take ownership and really identify tools and resources to help you become that expert NASCAR driver or that really good skilled engineer?
Yeah, I think the best advice I would give as a starting point is there's a lot of great folks out there, like your Heesoo Lees, your Steve Sandlers, your Heidi Barnes, Eric Bogerton, and they have a wealth of knowledge and experience. And a lot of engineers are really kind of shy or introverted. It's just a nature of engineers. I don't know, maybe you just, to be an engineer, you have to be shy and introverted. I wasn't wired that way, but I can tell you, growth and comfort never go hand in hand. And so if you really want to grow, you need to be uncomfortable. And in any case where you're growing your career, you need to get out of your box and reach out to those folks, because they're always willing to share ideas and work with new people who come with something fresh that they haven't thought of, a perspective. And so I know, because I work with all these folks. Hee-Soo Lee is one of them here. I mean, we've done multiple papers together. I have a blast every time working with Heesoo Lee. He always brings different perspectives and angles and a levity that makes it fun, right? And so every time we come out of it, we've always learned something new together. Heesoo likes to say that sometimes with some of our papers, I've been a bit of a slave driver, but we always have fun. With one of our papers, right? Because things kind of come up to the 11th hour, but that's normal with a lot of these papers. But in a nutshell, you have to get out of your box. You have to reach out. You have to ask, right? And the other advice I give folks, besides what I said previously about growth and comfort, is the answer is always no unless you ask. Always no.
Right. I I've talked about this before. I share that. If you can believe it, I used to be a very shy person, but there's things that I wanted to get after and do and aspire to. So I actually began to relate discomfort with growth, which is kind of a weird thing. And, but I totally resonate with that. Heesoo, how about you as a young engineer? Did you have that experience of sort of perhaps stepping out of your comfort zone or reaching out to mentors? What I hear you saying, Ben, is mentors. Like, go
exactly
after it.
Saying.
Don't sit in your chair and hope it's going to happen, or passively watch YouTube videos.
Yeah, and you have to drive it. It's on the mentee to drive that relationship. I have multiple mentees, but it's on them to drive it. And you need to set that expectation. The mentor should rise if he or she's a good mentor to meet that mentee's level of energy. But it's on the mentee to drive that relationship. I have one more plug, and I think Heesoo might counter with. I definitely agree with this. Is I use other tools like ADS. Like, if I don't understand something, I can build that and do permutations to understand something. That's the other thing that I'll use. And so you need to have these tools, right? And you can work with these mentors to help you learn those tools.
Yeah, from my perspective, a couple of things I'd like to add. I talked about the engineering curiosity, and I always choose a band as one of the person in a non-stopping engineering curiosity that keep asking why, and then also, always bring up the what if, right? And that drove us into a, kind of time period work non-stopping. That was the one case that we worked on one of the design com paper, and one day he sent me an email saying that, oh, this data looks strange, there's something going on, and asking why, right? There must be a problem with a tool doing something wrong. And that's where your engineering curiosity coming in, and then we asked it a lot of questions why, and also did a lot of what if. But going back to the other kind of story I was telling, and it was a fundamentals, right? If you touch on the other fundamentals, it cannot be happening that way. So there was something we learned out of that kind of example, pretty interesting way. This actually built up our core strength much stronger, and helps the engineers to build their career better. But interesting parts, from my perspective, I was thinking about when Ben was talking about the engineers are shy, right? I was thinking about myself, and sometimes I feel shy. But why people are shy about things, especially for the cases of engineers, I think it's more like a confidence. And confidence means, okay, I know the this much, right? However, is that really the knowledge at a top notch, or it's just normal knowledge? And that brings people into the kind of modes thinking about, is that something I need to step up and try to in order to get to that level, I think confidence level, must be very, very high, right? This is where also, the story I was telling in engineering curiosity and asking why and validate and do the old what if, that was the one case Ben talked about is a permutation. And you build up your confidence level. And once your confidence is built, then I don't think people will be, that shy. It's because they have a, belief on what they're understanding and
Right.
also what they're doing.
I think that's so true. But you have to be willing to have some failures along the way, but not see them as failures, right? See them as a natural part of the learning path, right? And
Correct.
like they say, fail fast, like keep going, right? So,
Yeah.
we've talked a lot, and I think it feels a little philosophical, but I think it's really important for engineers to think about these things. And also, I've talked to others that have talked about how engineers, say, come out of university or earlier in their career, and they get on a design team and they're quiet because they feel like, oh my gosh, I'm supposed to know all this stuff now. And so they feel like, I won't ask. I'll just pretend like I know it or just shake my head. And the truth is we're all that. Like, no,
Yeah.
that's normal. And so I
Yeah.
think part of what's good about this conversation from two pros is saying, this is a normal part of the process. Go ahead, step in, ask questions. And then when you get the competence, you get the confidence, right? And you can move past that. Okay, Hee-Soo, probably the last question, because the time is flying by, is let's shift now from our, the important part of the conversation, which is the engineer and how to build that competence. And Hee-Soo, because you're from Keysight, and Ben, you've told me this too, and so has Steve Sandler, people have taught me over time that Keysight is one of the few companies where you can do end-to-end, which is really unique and very cool. But there's also a trend with companies like Keysight or Ansys to be integrated in other EDA tools. And I'm just curious about that trend. And so how do you see this rising trend towards the connected workflow for engineers in the form of EDA, either tools end-to-end like Keysight or integrations, may help or hurt engineers? Or, what does that look like to you?
Yeah, that's a pretty interesting one. I have probably two things I'd like to talk about. One is, here's one case I'd like to just bring it up. And when I was doing data more of EM, let's say here's one design, and we are asking data engineers to go and simulate them, right? The data, what they have is basically geometry of the structure and material properties, right? And possibly, having some kind of port locations, right? And giving this structure to 5 different engineers and ask them to get me the results, right? One thing I learned that out of that trier, the 5 answers out of the simulation, to do the more EM simulations, it was very interesting to see that the 5A data is not the same. The question is why, right? As long as you follow the kind of steps, definitely the answers are getting close enough, but they're not exactly the same. It's because it's not just geometry, material properties, but also how you define the structure, right? This is one important thing I learned that this is also getting back to the engineers knowledge, which is very important. But having said that, one more important thing is conceptually constructing the learning organization, because every time you do something, you learn something. Then how are you going to build that structure or that knowledge into your thought process and flow, right? This is one of the critical important things. Having said that, you have to think about when you are running the any of simulations or designing something, you need to think about what is the end product or end results, what you're looking for. This is where I see that, you start with the idea or concept, and you go into design, and you go into simulate, and then you go and then construct the system or board, and manufacture it or fabricate, and then go and measure, which is a validation process. So thinking about this process, I need to go over and over based on the quality of the design. But important thing is, what if, we go and then design and validate data or results as the way you're gonna, validate by measuring it, right? This is one important part of the process, what we call connected flow, which is bring the process of doing the validation into the simulation process. Therefore, at the end of the day, when you are checking your design, not only for the design you simulated, also manufactured one, you're gonna have the same bar, right? So that's one of the important thing, and we like to actually support the industry by making the solution, from the simulation to measurement in a consistent workflow. One example I can tell you is a compliance. When you design the high-speed systems, throughout the standard, you must have the list of things you need to validate against the specification. For measurement side, there is a compliance application software. So when you measure your design or board, you go through your compliance apps and make sure your design is meeting the given the specification. What if you bring this process back to simulation, right? Then you are actually closing the gap of your design from the design stage to the final production stage, so that you have a better chance to make the successful design run. So this is important a process, again, called as a connected design flow. We at Keysight is the only company that does a design and test. So we are making the workflow, really, making this work process, more stronger, so that we can help the other design engineers to make their design much faster and better way.
So that's putting all the right tools, and one is taking the hope out of the design process.
Correct.
So you know what you're going to see. You pull the simulation earlier in the design, and then when you get the physical product and test it, you know what you expect to see, and hopefully you've done sort of the heavy lifting mid-design, so you don't fail at the bench, and then you have to respin the board and start the whole thing over again. Does that sound familiar, Ben?
It does. I've used some of these tools that Heesoo's talking about to basically build complex system models, and used ADS to help me validate that. Yeah.
And then, like, I'm sure, Ben, you've seen across your career the ugly, messy way of doing it.
Oh,
right?
yeah.
Which is using physical prototypes over and over and guessing. And we always call it whack-a-mole. Mm-hmm. It's like, where it is? I don't know. We'll just try to move that thing and see how it comes out next time. Right. So what does it save? Time, money, headache, stress. I mean, there's so much at stake.
I mean, in this day and age, people want to be down to one board spin. They don't want to do other board spins. Yeah. And you have to have tools like this to enable that workflow.
I know.
That's really the key.
And as much as, we're all Team Keysight here, I am encouraged by finally, we've talked for decades, since I've been around a while, about living in these siloed, competitive, zero-sum games, sort of, but in this kind of worldview, and it doesn't work anymore. And it's like things are so complex and fast now. I don't know that you can afford to do that, actually. And the chips are so expensive, and it's getting to that point. And that being said, I am encouraged to see what we're previously saw as competitors, right? That Ansys or Altium or some of these tools are playing nice together now. Dream-wise, I'm sure everybody would love to have the end-to-end Keysight solution, but, people have already invested in other tools. And so it's nice to see that flow happening too. Do you think that's a good trend, Ben?
I would. Yeah, I definitely think that's a good trend. And I can say for a fact that I've used some of those, like Ansys, for example. You can open RF Pro, which is a Keysight EM tool, and pull an Ansys license, set up an EM simulation with RF Pro, and switch it to an Ansys HFSS simulation. So these tools are realizing, all these companies are realizing that you have to do that because things are moving too fast, and somebody doesn't want to import a design and then run it in one tool and then have to re-import it and set it up in another tool. That doesn't make sense. That's not efficient.
Such a headache.
Such a headache. Already does that, right? Like if you want to run COM, for example, channel operating margin, pretty sure Heesoo is instrumental in getting the plugin set up with MATLAB, which is running under the hood with ADS. When you run COM, that's built into ADS. So it's running Rich Mellett's basic scripts, right, from what he created in MATLAB. And that's all a different tool, but it's built in ADS. You don't need another license for that.
I think this is so good for engineers, and I'm glad you two have validated, again, as a non-engineering professional, that to me, I think this is a really powerful trend. Well, gentlemen, I think I've taken enough of your time, but thank you so much for sharing your experience and your wisdom and your thoughts, both on engineers and on tools and on connected workflow and EDA. I really appreciate your time and everything that you so generously share with the industry.
Thanks for having us, Judy.
Thank you. It was great.
Thank you. For our audience, thanks so much for joining us today. I hope you gained wisdom and insight from Heesoo and from Ben. We will see you next week. Until then, remember to always stay connected to the ecosystem.